So the last time we spoke about Monte Carlo simulations. Now, this time we'll explore another technique which we use, which we call as a finite differencing scheme or a finite difference grid, I would say. So the way in which this is structured is, so maybe, I can just read the point from here and I can write it on the whiteboard because the space here may not be enough. So allow me to just switch, just open paintbrush. So in finite differencing, what I try to do is I try to convert a differential equation into a, sorry, I think I just reshared presentation again. My apologies. I mean, I have to switch to whiteboard. So what we have is a differential equation which we are trying to solve. So something like a Black-Scholes partial differential equation. Now, a partial differential equation we know is a continuous time representation. Now we have to represent something in the form of a grid. So you can imagine like a discrete grid, whereby we have a sets of rows and columns which are together, and we work on this mesh grid. So now we have to move from something which is in continuous time into something which is in discrete time. So the way to do that is to convert your differential equation into a difference equation. So that's basically differential to difference. So if I can have this kind of a conversion which is happening, then I can start addressing each of these nodes. So imagine this is just like your grid in Excel. So this will be the asset and this will be the time steps. And I would have, for the time, I would have two terminal points. So at 0 and at capital T, because I have a certain time horizon, right? So I have a certain time to expiry. So that capital T is known to me. Now, how much should the stock price rise? Now, ideally, this should go to infinity. But in if I do it in practice, I cannot have infinity, right? Infinity doesn't exist. If I do that, then my code will never stop. So I will take a large enough value, which cannot be reached ideally, because I need some upper bound in order to mimic infinity. So I take a large enough price for or a large enough boundary for this, and I set it as a cutoff. So I'm going to have my grid until those points. So imagine that that boundary is here. So rather than here, let's say this is the boundary. And I'm going to work on each of these nodes. So I start with my terminal nodes. And then I keep stepping back in time. So I start from here, I work on valuing the option at all of these nodes. Then I come back. I will fill up this second rung of nodes. Once I do that, I again step back and so on until I reach my time step equal to 0. So this is my target cross section, you can imagine where I'm trying to go. So once I do that, my job gets done, because finally I am interested in what the option MTM is today, or standing at small t equal to 0. So once that is done, my job of pricing the option or calculating the fair value of the option is possible. And for that, I start from the terminal condition and I keep stepping back in time. So does this sound okay? Any questions for anyone? So how that is done, we'll see. But at least the approach, does that sound okay? Okay. So what I would like to say is, let's say I have I number of asset steps and I have k number of time steps. And if I were to show the size of these time steps and asset steps, this you can imagine is like a delta S. So So you have I number of delta S increments which you are having in this range, and here I have a delta T. That is, I'm taking these small steps along the time axis. So now I have some movement along the asset axis and some movement along the time axis, and that will help me address each of these nodes. So you can imagine this is just like an array which I'm trying to loop through. So is everyone familiar with the concept of arrays? Have you worked on that before? So was this covered as a part of your business analytics class? Because we are going to require arrays here. Okay. So in your other class was NumPy library covered? So as a part of your analytics class.
Sir, we covered only basic rudimentary elements of Python, not exactly very in depth like you are describing,
Oh,
sir.
okay, understood. But did you guys develop anything in Python as well?
Sir, we had projects for our last exam.
Okay,
We were given time series data and other projects to work on.
okay. So I think you guys must have used a data frame or something, I believe.
Yes, sir, from Kaggle. The business analytics was done by someone from outside the college,
Okay,
and they provide us with the data set and to provide and to do analysis and provide the conclusions.
okay, understood. So just to give you an idea of arrays, you can imagine arrays is a collection of data points. So why I require a collection of data points? Because let's say I'm working on this last time step. So on this cross section, I have n number of points, or I have, let's say, I number of points as per our convention. So I have these many number of points which I need to take care of. So to do that, I need some way to address each of these points. Without this, I cannot calculate how much is the option price at each of these nodes. Now, in order to do that, arrays is one of the convenient ways to do it. So whenever you have a larger data set to handle, you always try to move things inside an array and then you try to work with it. Now in Python, you have a data frame as well. So that way you move everything inside a pandas data frame and then you start looping through the data frame. But uh, but finally, I mean, both of them point to the same thing. So even in other languages, something like a VBA or I'm sure in R programming as well, you'll have arrays which you'll work with. So your arrays could be anything, collection of numbers or maybe collection of strings, etc. So any data points which you're trying to handle together, you try to move them inside an array and then you handle it. Yeah, someone raised the hand. Yes, Mir, please go ahead.
So, would it be fair to say that it's like a kind of scatter plot, or to oversimplify
Uh,
it?
so you can say, so yes, I mean, elements in an array can be represented in a scatter plot. So if that's how you would like to interpret that. So you can imagine there are n number of points inside an array, and all of those data points can be represented in a scatter plot. That is possible. So
Okay,
that
sir.
is
Thank you.
something like this. So if these are all my data points, I can combine them together and put them inside an array. How do I want to arrange it inside an array? That's a different question. Do I want to arrange it asset level wise? Do I want to have it time wise, etc.? But yes, and you can combine everything and put everything together.
Sir, do we use clustering, if I'm not mistaken?
Not really. I mean, so here clustering may not be required because that is something which you require for machine learning. But for this, we don't really require clustering as such. No.
Okay, sir.
Okay, so this is the rough structure which I have in mind. Now, how do I address each of these points which are in between? So let's say I'm working on one of the points here. Let's say which color have I not used? I can use orange. Let's say this is my point of interest, the orange circle. That is, this cross section is of interest to me. Then I may want to address this as something like a VIK. So just a representation which I would want to address this point. That is, I'm calling V as the option price. I is the so the subscript I represents the asset step, and K represents the time step. So I would like to use a representation like this whenever I'm moving from a differential equation into a difference equation. So, so there are ways in which you can convert your differential into a difference equation. We'll talk about that as well. So we'll take the Black-Scholes PDE, which we had done the last time, I think, in the last week, and we are going to use the same thing to be solved numerically. So the Black-Scholes PDE would look something like this. So this was your partial differential equation, which we had derived in the last week through simple applications of Ito's no arbitrage and delta hedging. So now let me introduce you to, at least briefly, the concept of option Greeks, because all of these are terms which are very similar to Greeks in an option. So in options, we have what we call as Greeks parameters. So we'll talk a bit about Greeks in one of our subsequent sessions as well. But just to give you an idea, now we need some way in order to measure the risk for an options portfolio, because take a bank or a financial institution, they will have a large position of options within their books. So they would require some way to address that risk, because both from reporting as well as daily risk monitoring, they require some metric, isn't it? So option Greeks happens to be one of those popular metrics which we can use for addressing this requirement. And we are anyways discussing plain vanilla options. So that way, first order Greeks are good enough. And we'll just use a gamma as well, which is just a second order, but it's it's related to the delta bit. So that way you can say that we are working only on the first order Greeks, which is good enough. So we'll have four Greeks. So let me just end this then. So we have a delta, theta, rho, vega, and gamma. Now, as a part of this equation, we don't have all these Greeks. We only have a few of them. We'll talk about that. So delta is defined as, so let's say if I call V as my option price, and let's say S is my underlying. So let's say V is option price, because I'm going to use these terms to represent these equations. S is the underlying. So we'll take a stock here. So the underlying stock price. R is the interest rate. Sigma is the volatility. And T is time. Now, if I have to represent these Greeks, so let me write them first and then we'll talk about it. So I can represent delta as something as dabba V by dabba T. Sorry, dabba V by dabba S. So that is, delta gives you how sensitive your option is to a change in the underlying. So V is my option price and S is the underlying. And DS is nothing but a small change in the underlying. So that way, through delta, we try to approximate what would be the impact on an option price for a given small change in the stock price. Next, we have a theta. So we'll run through the list completely and then we can take questions if any. Okay, right, this is dabba V by dabba T. So theta has to do with time or with passage of time. So theta is defined as sensitivity of your option price to passage of time, also called as time decay in many textbooks. Rho is given as dabba V by dabba R. That is the rate of change of option price for a given change in interest rates, small r. Then vega is given as dabba V by dabba sigma. That is what is the impact on an option price for a change in volatility, which is represented as sigma. And gamma, this is a second order Greek. So you can write this as d2v by ds square. Or I want to simplify this as d by ds of dv by ds. That is the rate of change of delta, you can say. So gamma is a higher order Greek, or it's a second order Greek, which is nothing but a measurement of a rate of change of delta, which becomes evident from this representation. So I have a d by ds into dv by ds. I know dv by ds is nothing but delta. And d by ds of this delta will be the rate of change of this delta, which I call as the gamma. So these are a few Greeks which we popularly use. Now, any questions in this? Now, we'll talk a bit about Greeks in our subsequent class, but at least the idea of Greeks is that okay? Okay. Now, if you look at the Black-Scholes partial differential equation right here, we'll see a few of these Greeks are figuring here. So, if I look at the first term, dv by dt, can I say this is like a theta for the option? But this is exactly similar to the theta equation which I've written here. Then I have a dv by ds. Now, can I say this is a representation for an option delta? Because it's very, very similar to the delta bit which I've written here. Then I have a d2v by ds square. Can I say this is like a gamma for the option? Because it's very, very similar to this gamma representation. So that way, and these are a few Greeks which are figuring as a part of your differential equation as well. And we want to convert this continuous time representation into something which we can show via this grid of finite differencing. That is, I want to represent these terms in a simplified form so that I can explain them in terms of VIKs, where VIK will be my representation for each of these points. So as I move along the axis along the y or the x axis, these indexes can change. That is, let's say, if I move along the time axis, this can change to something like VIK plus 1. That is, if I stay at the same asset level, that is, let's say, if I had to show you movement along time and asset. Let's take a small grid here. So let's say I want to show this movement along time and movement along asset. So let's say I'm standing at this central point here. And let's say this is my VIK. Now, if I want to show movement along time, that is, I stay on this same asset level. That is, I'm not moving from this level, which I've represented by a red arrow, but I'm simply moving along the time axis here. So let's say I want to move from this time to the next one. Then this index will, I mean, if I had to show this in the form of this representation, it will look something like VIK plus 1. That is, I'm holding I constant, but I'm changing k by 1. So I can do it as VIK plus 1. Similarly, let's say I want to show movement along the asset axis. That is, let's say I freeze on this time step. So time step I'm not changing, but asset I want to move. So I'm here, and let's say I want to move to the next step. That is, I want to move to this point here. So here my representation of VIK would become something like VI plus 1k, because my kth step is remaining as it is, but I'm moving along I, because I have I which is along the y-axis and k which is along the x-axis. That is, I is a representation, or you can imagine it's an iterator along my uh, asset axis, which is S, and k is the iterator along my time axis, small t. So that is how my representations would change. So does this look okay? Okay. So now we are going to attempt to convert all of these difficult, I won't say exactly difficult looking differential equations, but these differential terms into something in the form of VIK. Because I can't really implement a DABA V by DABA T directly in a program. It's not possible. This is continuous time, so representing that through a code would be difficult. But an easier way to do that can be to convert this into a difference equation format. And once I convert that into a difference equation, then I'm good. Then I can start looping across this entire mesh as well, or mesh grid as I may call it. So let's understand how to convert these terms into VIK format. so that we can implement them in our hands-on model. So should we try that? Are we good? Okay. So I just erase this. Now, again, when I say we are working on numerical techniques, we are working on numerical approximations. That is, we don't have an exact solution, but we have a close enough solution to the expected value. So that's why whenever you use numerical techniques, you say that you're working on a numerical approximation. You cannot have an exact answer, but your answer will be very, very close to the expected value. So again, the terms which we are going to convert from this differential into a difference equation format, all of these are more of approximations. So let's start with theta first. So theta is something like a dabba v by dabba t. So if I show a mesh grid here so that it becomes easy for us to visualize what we are doing. Let's keep this mesh grid common for all the three terms. Sine small t, and this is the asset S. And I'll be working on, let's say let's say I call this as VIK. Let's say this is my VI. So one way to approximate theta, let me switch colors as well. Now I can show theta or dabba v by dabba t equal to. Now I want movement along the time axis, right? So that is my k should change. I have to hold the I constant because I have to see how much my value is getting impacted for a change in the time step dt. That is my denominator is the component which is showing me the quantum of change which is happening, and accordingly I'm trying to measure the impact on dv. So one way to write this could be, I can write this as VIK. Now I need to hold I constant because let's say I'm on this asset step, I need to remain there. I cannot move along the asset step, isn't it? Because now my job for this theta is to move along the time step. So this could be minus VIK plus 1 upon delta t, because I have these the quantum of these time steps is delta t, and the quantum of these asset steps is a delta s. So does this equation look okay? I've simply tried to represent terms in terms of this VIKs and this delta T, because I have to somehow get rid of this continuous time representation and move on to something which I can solve via coding logic. So how to solve this, etc., we'll see in some time. But until then, we'll look at the other two terms as well. So one was theta. Second, we can look at the delta term. Now for delta, I have the equation as dv by ds. That is, I want to see how much my option is getting impacted for a change in the underlying stock price. And underlying stock price is something which I represent by ds. So here the movement should happen along the I-axis or along the asset axis. That is the subscript which I've written here, VI, that should change. Because if I don't change I, then that will not allow me to move along the asset axis, isn't it? Now, when I hold I constant, something like this theta, I'm staying on one particular asset step. I'm only moving along time when I do k and k plus 1. But when I do delta, I need to move along the asset. At the same time, I want to stay along the one single time step. So that way, my value of k should not get impacted, but value of I should get impacted. So does everyone agree with that? So a logic very similar to what we have done for theta. Only thing is here we are trying to assess the impact along the asset axis and not the time axis. We'll be holding the time constant here. In theta, we are hold the asset step constant. So I'll just write it here. And this one will be holding time constant. So everyone with me up till this point? Some things may appear slightly tricky at the moment because these are things which you're seeing for the first time. But logically, do they sound okay? So there's no need to memorize these formulas as such. You will gradually visualize them over time. But logically, are you able to relate what exactly we are trying to do? Does anyone have any questions as to why we are doing these things? So have I addressed that basic question first? If anyone has still that question in mind, please feel free to bring it up. Because unless we answer that, there's no point in doing this. Okay. Now, there are a few ways in which delta can be calculated. Now, why I say there are different ways, because all of these are numerical techniques. So numerical techniques can be implemented in a certain way. So generally, the model developer decides on the most optimal way, because when you talk from developing a certain model, you have to look at two things. One is your efficiency or your accuracy of the model, and second is your maintainability and developmental effort. Because finally, if you're building this for a client or maybe for a bank, then you'll be expected to complete this within a certain time period. At the same time, you may be having a certain maintenance contract which may be signed with you. So at that time, you have to ensure that your code is manageable. That way, if the bank or your client comes with a requirement for a certain change in the logic, that is something which you should be easily able to do. So I would say from any modeling effort, always keep these two things in mind. One is model accuracy plus efficiency, and second is ease of model management or ease of your code management. So any kind of enhancements which are to be done, that should be done with ease. So one way to ensure that is to avoid as much amount of hard coding as possible. So the problem with hard coding things is it reduces your flexibility of models. So when I say hard coding of things, that is if I'm using a certain variable, let's say variable A, and I need this variable to be plugged in with certain value. So there are two ways to do this. I can either hard code this in my code. So I can say, let's say A equal to 5. Or the other better way is A will be a value which will be fetched from, let's say, a user input field. So let's say this is my user input field, and the user is inputting the value here. So A equal to something. So let's say a user plugs in a 4. And I represent this 4 by, let's say, an I. Now this I is different. So let me just change the variable name. There should not be any confusion. So let's say I represent this variable name by X, let's say. And what I do is within my program control, I equate A equal to, or I move this X into A. So that gives flexibility. So tomorrow, if the user decides to change this 4 to, let's say, 14, it's not a problem at all. However, if I do something like this within my code, then user has to every time open the code and make this 5 to any value which is required, which is not an advisable practice, because inadvertently, if the user makes a change somewhere else, your entire model can start working incorrectly. So that way, try to have as much amount of robustness in the model, try to avoid hard coding, and try to keep it either menu driven or maybe something which can be easily handled through simple Excel inputs or maybe any other user input fields, because not every user using the model will be comfortable with the programming bit or model development bit. So you may develop it really well, but you need to have the interface in such a way that it becomes easy for consumption. So, uh, yeah, so there's a raise hand, but yeah, Mir, I'll come back to you in a second. So even as a part of my client deliverables to the customers, I generally deliver them a .exe file, an executable file. The advantage of exe is the client doesn't have to worry about how to run the model. They simply double click the executable and they have the output ready. So that way, within that executable will be your entire coding logic implemented. So if I'm using open source, this becomes very, very easy. So either Python or R, you can easily wrap those codes inside executable and deliver it to the client. So whenever they have to run their model at their end, they simply click it, either manually click it, or they have a batch process to double click, which will actually double click this .exe through an automated process and generate the required output. So that way, model management becomes easy. So client is also not worried that any inadvertent or maybe deliberate changes anyone is doing. So that can't happen because .exe file doesn't give you access to the underlying code. It only gives you access to the working logic, which is finally what the client demands. Yes, Mir, please
So
go
it
ahead.
was the same question whether the it can be automated, the calculations can be automated or no. You answered it. So,
Correct,
so
correct. Yeah. So have you guys covered this as well in your analytics class? How to convert things into executable? So how to convert a .py file, or maybe I don't know what is for R. It may be .r. I'm guessing. I don't know R programming. So if I'm incorrect, please let me know. So maybe converting something like this into a .exe file. So was this something which was covered as well?
No, sir.
Okay, but there are ready guides which you can definitely check. I mean, a couple of simple functionalities. So if I recollect, I don't know for R, but for Python, I think there is a Py installer. So I have it installed. I have something installed on my other laptop. So I think Py installer is one, and I think the other one was AutoPy to exe, something like this. AutoPy to exe. So you can just install this utility inside your Python installation or inside your Python package manager and then start using them. So you simply send this .py file to this Py installer or this AutoPy to exe, and it will create a independent folder which will have this .exe file. So that folder will have other dependencies as well. You don't have to worry about that. So when you deliver your thing to the client, deliver the entire folder. So all of the dependencies are there inside one single folder. So once the executable runs, it will find whatever it requires inside one folder. So your client doesn't have to install anything at their end, because many a times clients do not want to install new softwares on their systems. So they may say that fine, we have our own independent systems and servers, but we want to avoid any additional overload onto them. So can you give us something which is light? So this .exe takes care of all dependencies. Otherwise, if you talk from a Python perspective, you require a Python interpreter, you require Anaconda or any other package manager, something like a Miniconda, and you require a IDE, uh, either a Jupyter or any other IDE which you like. But again, the problem for that is the client may not be willing to do that, because the client may say that our technology teams, although they won't have a problem, but we are not very keen to install something on our system. So at that time, if you give them an exe file, that cuts through all of these problems. I mean, exe can run anywhere. So that is something which you can definitely check out. So I'll just erase this right hand section. Now, a few ways to write theta. One is what we call, so I'll tell you the three ways, and generally I'll tell you the one which is preferred in by market participants. So one way is through a forward differential. So yeah, forward differentiating would look, I have to move along the I-axis, right? So Vi plus 1k minus Vik upon delta S. Or there is a backward differencing as well. So something like Vi, again movement along the I-axis, minus Vi minus 1k upon delta S. Or thirdly, there is a central difference, something which we generally prefer. So again, there is no hard and fast rule which says that you have to use one or the other. You can choose any one which you like, but generally people prefer this central differencing technique because it has shown to give better results comparatively. So through central differencing, it would look something like vi plus 1k minus vi minus 1k upon this delta s. So 2 delta s. So you can use any differencing technique you like, and there will be no problem because there is no regulation which says that you have to use one differencing technique over the other. Nothing like that. Pick any one which you like, and you can use it for your analysis. But generally, this is a preferred one because the solution is much more stable and the output is much closer to the expectation. So this is something which we will do as well as a part of our hands-on thing. So I'll stick to central differencing. Later on, you can just try out these other things as well. So there may be small changes which happen for each of these techniques, something which you can definitely explore. But again, now this is our attempt to convert a continuous looking term, something like a dv by ds, into something which is in discrete time, which we call as the differencing equation. So again, this representation, how that is to be done through a coding logic, we'll again see. And the advantage is once we have things which can be represented in this fashion, you can easily use simple looping and conditional statements in order to um, solve for your model. So conditional statements also might not be required too much. Looping is something which we have to focus on more. So have you guys used looping before? So do you know how to use a loop? So something like a for loop or maybe something like a while loop. So has that been covered as a part of your other class? So loops and conditional statements. Was this covered? Okay. So was it covered for both the classes, for IB as well as for financial economics? So is everyone familiar with the operation for a for loop? Because this is something which we are going to require for solving these kind of things. Okay. And is everyone familiar with a nested for condition? So let's say I have a for inside a for. So how does this work? Anyone? So let me give some numbers and then we can quickly discuss because these things are something which would be required. So of course we'll do some simple hands-on before we do our actual coding, but till then. So let's say I have something like, so since Python or R has been covered for you guys, this is something which you may be familiar. So let's say from I equal to 0 or maybe I1 to 10 and for j equal to 1 to 10. So would anyone like to try how exactly this nested for condition would work? So I running from 1 to 10, which is my outer for, and j running from 1 to 10, which is my inner for. So how would the program control function here? Anyone? Because as a part of your machine learning bit as well, you might have used these things. So can you recollect that? Or maybe something which you have done in the past.
Yes, we do it to find, like, let's say optimum values of, let's say, we are running KNN clusters, no, not clusters, KNN, K nearest neighbors,
Mhm.
to find what is the best K that gives us the best answer.
Correct. So yes, I mean those are advanced concepts. Now, if we take a step back, would someone like to attempt how this control would function? How would this I and J function, or how would these two for loops work?
So basically, because J is written second and I is written first,
Mhm.
first for I equals to 1, it will run from J 1 to 10.
Correct.
Then for I, when I is 2, it will again run J from 1 to 10.
Very good.
So
Yes,
basically, the one which is inside will be running out loops, and the one which is on top will happen after that.
absolutely. Very good. So as Neil rightly said, and the outer loop will run one at a time, whereas let's say for I equal to 1, for this first increment for I, j is going to run 10 times. So once j completes 10 times, I come out of the inner for loop, I becomes 2, again j will run 10 times. So these are a few things which will require as a part of this as well. So either for delta or maybe in the gamma condition, we may require some additional looping, because the thing is we want to move along this these steps, right? So that way, and I expect that we are going to require some nested for conditions again when we do the hands-on. Let's see if we require that, but I feel this would be required. So correct. I mean, this is looping, and we are going to use looping extensively. And is everyone familiar with conditional statements as well? So something like a if condition, if then else. So have you done that in Python or R as well? So if some condition, then something else, something. So the way to so this is what we call as a conditional statement, because I have a condition here. So let's say my condition could be, let's say, x greater than 10. I'm just taking some hypothetical condition. So if x is greater than 10, x is some variable which is coming in. If this is satisfied, I execute my first portion of the code. If it fails, I go to the else portion and I execute that. So that is how we can use if and else conditions as well. There is a else if condition also. So I may have multiple conditions which I want to check. So it could look something like, maybe if x is greater than 10, then else if x is greater than 9, then something, and else condition. So that way, this is also what we call as nested if conditions, which we can write via a code. Now we can write these if inside your Excel cells as well. So that way, even in Excel, we do a equal to if. So if you recollect, in our Monte Carlo simulation bit, we had one small if condition whereby we had done the barrier options. So if that maximum value is never reached, then we keep that variable as 1 or we keep it as 0. So we had used the if then else logic there. So the same thing we are trying to write it through a form of a code. So if the first condition is satisfied, then do something else if. Check for the second condition. If this fails as well, then you always have an else block to execute. So this is what you call as conditional statements, something which we are going to again require as a part of our logic. Along with for loop, there is a while loop as well. So let's see if we have to use a while loop going ahead, if required. But otherwise, for is a very, very popular way of doing things. So we will definitely be using for. Let's see if we have to use while anytime. Now let me write approximation for gamma as well. So the way in which you can represent gamma. Okay, just erase this. Let us approximate gamma. D2 V by V's. Now again, we are going to finally use central differencing here. So again, central differencing is like a preferred technique which we generally use, and that is what generally the market follows as well, because the stability of central differencing is far better. So we have one. So we are going to combine forward and backward differencing together in order to reach to that central differencing bit. So let's see how that is done. So firstly, through forward differencing, we have something like Vi plus 1k minus my time step remains the same, my asset step is moving upon delta S. We have a backward differencing as well. Vi, so I stay on I stay on kth step minus Vi minus 1k. So something similar to our delta representation, which we had done some time back. Now, as a part of the central differencing scheme, something which we generally prefer. Through central differencing, we have to take the rate of change of delta, right? Because if I break this up, this would look something like a d by ds of dv by ds. So there is a rate of change term here. because this delta is already captured as a part of this bracket. This d by ds is the rate of change. So that is what we try and capture here. So we would have these first two terms because these are my deltas essentially, and I want to see the rate of change, right? So I'm going to write those two, I mean, these two terms once again, but I need to adjust them a bit. That is, I need to take the rate of change. So Vi minus 1k upon delta s, the whole thing divided by delta s. So this is how I would like to approximate through central differencing. That is, I want to approximate the rate of change of delta because the numerator is nothing but the change in the delta which is happening. Because I have a dv by ds which I can represent either through forward differencing or backward differencing. So these are my respective deltas, and this is the rate of change basically. I'm taking the difference between them, and I'm taking this asset step as delta s below. So if I were to simplify this a bit, this would look something. So I have delta s as common. So vi plus 1k minus vi. So this would look something like vi plus 1k minus these two vik's would add. So two vik's plus vi minus 1k upon, this would be delta s, so delta s square. So this is one way of approximating gamma. So that way, what you are trying to do now is try to convert something from a difficult looking differential into something which is comparatively manageable through a piece of code. Now, now we can start thinking in terms of looping and conditional statements when we are trying to address this. And the idea is we are trying to solve something. So here we have a Black-Scholes PDE. Tomorrow you may have some other equation, but you can work in a similar space. So that way, let's say you're working on FX. So right now we are taking as a stock price. In place of a stock price, you can have FX rates as well. So that way you can use a similar setup there, only your asset would change from being a stock price to an underlying spot price. So you'll have a USD INR, Euro USD, whichever currency pair you're working on, and you can work on a similar setup. Of course, now with currencies, there is a small change in the process which happens because up till now, if you see, we have studied our equation as ds equal to rs dt plus sigma sdw. So this was something which we have used up till now. So if you notice, we had just one term R here, which we called as the RFR or the risk-free rate. Now, when we talk of a currency pair, something like a Euro USD, then here we have a foreign and a domestic currency. So I'm going to have two interest rates. So I could have something like R to represent domestic, RD, and maybe I could have RF to represent the foreign currency rate. So that way these two rates will come in. So my process will change slightly. The setup doesn't change much. So generally what you do for equities, you can apply it for FX with a certain level of confidence, and maybe some tweaks would be required here and there, but large scale changes are not required. Of course, this exact thing cannot be applied to interest rates because interest rates is a completely different asset class. So if you're working on interest rate modeling, these things don't work there. Of course, there will be similarities, but you cannot use it directly. So like equities and FX are pretty interchangeable, but that cannot be said about interest rates, or IR modeling as we call it. So talking of, so one point which struck me right now, talk of domestic and foreign rates. So how do you decide between a domestic and a foreign interest rate? What is the approach for that? So let's say I have a Euro USD currency pair. How do I decide which is the domestic currency and which is the foreign currency? So are you guys familiar with the concept of parities, etc.? Was that covered in your other subjects? Things like interest rate parities, or maybe Fisher relationship, or purchasing power parity, etc. So,
Yes, sir.
okay, so for Euro USD, how do I decide which is my foreign currency and which is my domestic currency?
So I think the base currency is the domestic currency.
Okay. Okay. So in this case, which one will be my domestic currency?
Sir, it depends on how it is quoted.
Okay. Uh, so so let's say I want to quote it in terms of per unit of foreign currency. Then in that case, how would exactly I approach Euro USD?
So depends what is the foreign currency over here.
Okay. So generally, so let me write one equation here, and then maybe we can talk a bit more about it. So there is a parity relationship which we write. So we have F equal to S into 1 plus R domestic upon 1 plus R foreign raised to T. So generally, what we do is an easy way to do this uh, is to look at any currency pair and figuring out which is the leading currency within that currency pair. So there are standard conventions which the FX market follows. So when you talk of Euro USD currency pair, Euro is the leading currency, and a leading currency becomes your foreign currency. Similarly, if you have something like a USD INR, now just because we are in India, we should not say that INR is the domestic currency. It has nothing to do with our geographic location. But based on the way in which the rates are quoted by FX traders, this is a quotation which you will see USD INR. So USD becomes your leading currency pair. So again, that is a proxy for foreign currency. So that's one way to remember what you generally see in FX markets. So that way, there are certain ways in which currencies are quoted. So we have something like a GBP USD, which is the frequent way of quoting it. Now, no one quotes USD GBP, although we know it's just the inverse. No one will say it is USD GBP because FX convention is to take GBP as the leading pair. So we have GBP and USD, and we have this R foreign, and we have R domestic. So that way, remember to start with, and those leading currencies in a currency pair become your foreign currency. And once you know what the foreign currency is, you can simply look up the foreign interest rate and you can use it in the calculation. So does this sound okay? So gradually, as you spend some more time in the industry, you will get to see these conventions, how these are written. So uh, it's never USD Euro, it's always Euro USD. So these are something which the market has been using over a very long period of time. So those conventions exist and we continue to use them. And the relation which I've written here is what we call as the interest rate parity relationship. So interest rate parity relationship basically talks about the relationship between FX and interest rates markets. An important relationship because we have FT and ST. These are our FX, or I would say these are my FX rates. This is my forward rate and this is my spot rate. And these are my domestic currency rates, RDC, RFC, which is nothing but the interest rate. So that way, an important relationship which combines two different asset classes, FX and IR, this is what we call as a IRP or interest rate parity. So, so the way in which your foreign or maybe your forward rates are calculated, you have this IRP logic which gets followed. So even if you open up Bloomberg screen, so if I recollect correctly, inside Bloomberg you have, I think FRD if I recollect. So you may have something. So let's say I want to know the forward rate for USD INR pair. So I think in Bloomberg the shortcut is something like USD INR. Then there is a currency button. So there's this yellow colored button on your Bloomberg keyboard, which you have the CCY. And I think this thing is FRD if I recollect correctly. So this will give you a schedule of forward rates. That is, it will be like two columns which you'll see. So you'll have tenors and you'll have forward rates. So a very, very convenient calculator. So just to give you an idea of how that would look, it is this much. So you have tenors and you have the forwards. So firstly, you have the spot, which definitely gets displayed. So this is not exactly a forward, but your spot rate will be given here. And then you have forwards, which are calculated different tenors. And these type of calculations can be done through an interest rate parity relationship. So this is an application of IRP as well. So if you once you get access to Bloomberg, so if you have Bloomberg anywhere so I think you guys have Bloomberg, right? Or you guys have Reuters in your computer laboratory. Because I think Ms. Kulkarni had mentioned some time back that I mean you have something in the laboratory. So if it's Bloomberg, then this is a shortcut which you guys can try out for Reuters, and you can generally try out USD INR forward, and it will show you something in the drop down. I don't recollect the exact shortcut for Reuters, but that is something which you'll easily find. But these are the type of things which traders frequently find it useful, because if they take a certain trading decision, they may want to look at how the forward rates are looking, and accordingly, they may want to take a certain trading position. So just something which you guys can explore subsequently. All right. So we are at 10:20 right now. So can we take a break for 5 minutes and we come back?
Yes, sir.
Okay. Okay. So it's 10:20. So let's regroup by 10:25 and we can take our discussion ahead. Can we resume, guys? Is everyone back?
Yes, sir.
Okay. So just running through the points. Have we missed anything? Construction of the grid is done. Basic idea of difference equation. Pictorial. Yeah. Final and boundary conditions. This is something which we'll quickly run through. So there are two things which we require to understand when we are doing finite difference. One is a final condition and other is a boundary condition. Because what we're trying to do is we are essentially solving a partial differential equation. And for solving that equation, we require to define these type of conditions. Now, a final condition in our case will be the payoff. Because finally we are trying to price an option, right? So we would like to know how that option payoff is going to behave. So that is our point of interest. Next is the boundary condition. Boundary condition basically sets the bounds within which we are going to solve this equation. So that bound can be on asset price as well as time. So these are the bounds which I would like to set on the asset as well as the times. So my asset could ideally asset will be from 0 to infinity, but infinity is not possible. So we are going to replace it infinity with some large enough quantity so that it will remain finite. At the same time, it is sufficiently large so that we have the entire scenario captured. And next is a time step. So time, there's no uncertainty, right? We have zero to capital T because capital T is known. We know the exact time to expiry for the option. So there is no problem in that. So these are what you call as boundary conditions. So once you define the final and a boundary condition, you can have a unique solution for a partial differential equation. So when we solve the equations, once we set these two things, we are good. Then we can start implementing them in practice. Approximations are done. These three techniques we quickly discuss. Excel implementation we'll do in a bit. All right. So we can continue to use Excel. Now we'll only need to use a bit of VBA here. So what we do is rather than directly starting with finite differencing, we'll do some basic hands-on things in VBA so that you guys get familiarized with that new tool as well. Because I know most of you know Python or R, but not many of you might have worked on VBA before. So has anyone worked on VBA, that is Visual Basic for Applications, before? Have you used VBA macros at any point in time? Open up. VBA is a very powerful tool as well because firstly it is within Excel, so it's an integral part of Excel. So if I share screen for a moment, so can I request all of you to open up your Excel spreadsheets, please? Just open up any fresh Excel spreadsheet. I've also done the same. So this is just a blank spreadsheet which I have opened. So if you see in the top bar, you'll have a so you may not have this developer tab which you see. So does anyone see this developer or but I think majority of you won't be having this developer tab because it needs to be enabled. So I'll show you how to do that. You go to File. Now, depending on which version of MS Office you're using, these menus can slightly be different, but otherwise, more or less, you will find this somewhere. You'll see an options. So go to options. Now, within options, I go to add-ins. Is it quick access to customize? Yeah, customize. So inside Excel options, can I request you guys to go to customize ribbon? And in customize ribbon on the right hand side block, you'll see this developer. So for most of you, this will be unchecked. So can I request you to check this and then press OK. So once you get there, let me know.
Done, sir.
Okay. Now let's start some simple hands-on thing. Nothing very finance specific, but something which will help us get started. So that that way, when we actually do our hands-on thing, it will be much more comfortable. So just to give you an idea of the VBA bit which will be working. So allow me to just switch screen for a moment, and we'll come back. So I'll just tell you a few important points which we require. Just share my whiteboard 1 second. So a few things which we require, which will generally give us an idea of VBA. So VBA is an integral part of Excel. So that way it interacts really well with the Excel bits. So whatever data is there in your Excel cells, you can easily drag it inside a VBA and work with it. So that's the reason why many clients still prefer to use VBA, because our legacy systems are still on Excel for most of the customers. And they may say that, fine, I mean, scripting is something which many people are using, but we want to still use Excel for our purposes. And many a times it's not possible to do everything in Excel. Especially, I mean, if you want to program something, then you can't really do it in plain Excel. You need VBA for that. Or for that matter, even these messy looking nested if conditions. So, and a few of my friends in the industry, they generally prefer these multiple ifs inside. So inside one single cell in Excel, you do equal to if, and you have almost 10 to 20 ifs or if or other conditions, which is immensely painful to decode. So the person who writes that will understand what that is. But if you have so many if conditions which are there inside one single Excel formula, it becomes immensely painful to track as well as to debug or maybe maintain later on. So a rather cleaner way of doing things is through VBA. So generally what I do is, whenever those conditions go to the second line in the formula, I simply switch to VBA because it's far more cleaner and it's much better to manage. So and that is why VBA is still popular. So of course now VBA doesn't support much of machine learning or big data side of things, because that requires some advanced libraries which we don't really have in VBA, because VBA would require you to work more in order to get that functionality done. But otherwise, for most of your regular data sets or maybe any applications which are non-machine learning centric, that is something where VBA can definitely come handy. So I would say any of these scripting tools along with VBA should be a good enough fit for you guys to address most of the problems which you'll come across, either from modeling or model validations perspective. So a few things to pertain to this. First thing is data types. Just to give you an idea of the data types. So in data types, we have the usual ones. So you have an integer, then you have a double. So double is a name which we give for a float data type. So those of you who have done maybe C++ or C# in the past, you may be familiar with float or integer type of data types as well. So integer, float, then there can be string as well, and so on. String, boolean, etc. So when I say data type, this will define your data type of your variable, because finally, whenever you're working on models, you're required to create variables for yourself. Because finally, looping or any other conditions, they require a variable logic to be defined. Now, once you have a certain data type defined, you know what that variable is associated with. So can someone quickly tell me the difference between an integer and a float data type?
Yes, sir. Integer is like 2 and float is 2.0. Simple.
Absolutely. Very good. Correct. So I could have something like a 2. So let's say I have a 2.4 as the input which I give to integer and float data variables. Then this will only give me a 2 as the output, whereas float will continue to hold the decimal as well. So this will be 2.4. So this is how you can differentiate between integer and float. Now in VBA, we don't really have a float. We call it as a double. So double is synonymous to a float. So depending on what you're working, you have to decide your variable type to be either integer or float. So one example can be, if I'm working on a simple counter, I can work on integers. I don't need to do anything on the floating data types. However, If I'm handling, let's say, FX rates, interest rates, etc., wherever there is a possibility that I'll be having these decimal points, then I have to go in for double. Otherwise, I'll end up ignoring those decimal points or numbers following the decimal. That is something which I don't want. Then you can have text or string, you can have booleans, etc. So that way, various data types which come to our rescue. So this was on data types. Then operators are very, very similar. So operators which you have been using in Python or any other language, so plus, minus, division, subtraction, all are very, very similar. So in division and multiplication. After this, you have looping. So looping, something which we discussed some time back. So generally popular loops are for and while. Okay, so this was on looping. Then condition statements, definitely through ifs, if then else. So condition statements basically help you direct your program flow. So depending on the condition, you can switch your program flow accordingly. So conditional looping. Then there's something which we call as a sub procedure and something as a function procedure. So just to give you an idea of things. So one is what you'll see as a sub, and other is a function procedure. So a sub, you can imagine, is just a snippet of code which has been designed to accomplish a certain activity. So for this, and you can just create a sub anywhere and you can write your functionality. So we'll do that in some time. So we'll do some simple hands-on bit whereby we'll create a sub procedure. And so that's one way of doing things. Now, whenever you're working from a modeling perspective, generally we prefer to use functions. So functions are also what many people call them as UDFs, or user-defined functions. So within Excel also you have two types of functions. One is an Excel inbuilt function, something which you already have in Excel. So for example, sum or average or STD/DEV for standard deviation, etc. All of these are your inbuilt Excel functions. You can call them inside VBA as well. So I'll tell you a way to do that as well. So that can be done. Other than that, you can define your own functions. So if you recollect, in Excel, whenever you're calling, let's say, an average, you just go to a cell in Excel, you say equal to, you type in AVE, it will show you a drop down for average. And you simply select that average, press a tab, and pass the inputs. So that's what you call as an Excel defined function. Similarly, I may define my own function. Let's say Ameya. So let's say this is my user defined function. So if this is the case, and once I open that file where this function is saved, I just go to any cell in Excel, I do equal to, I type in my name, it will show me in the drop down. I'll pass the required inputs into that, and whatever processing has been defined, that will happen. So that way you can have a user defined function as well. So once we build our finite differencing scheme, we'll see how a function procedure can be done as well. So these are a couple of ways in which you can build your functions inside a VBA or functionalities inside VBA. That's something which we'll not do right now, but something which you can check out later is what you call as recording a macro. So another interesting feature, recording a VBA macro. Now, this is something which you can use if you have certain tasks which are repetitive and comparatively easy. So when I say comparatively easy, that is you don't have any conditional statements. You don't have any looping. Maybe it's simple linking of cells and adding or subtracting numbers, or maybe just multiplying stuff, etc. So if these are simple and plain operations, which let's say you have to do day in, day out. So imagine that there are 10 rows of data which are coming in, and it's your job to let's say add all the 10 rows on a daily basis. Then for that you can have a VBA macro. So again, I've taken a simple example, adding two numbers. Now someone may say I can just go to say equal to sum and I can add them. So that's a manual operation, but you can automate that as well. So these simple kind of operations you can record through a macro. So that way you start a macro, it will record your actions and you save that macro. Now, once that is done, you can simply call that macro every day and run it. So every day, whenever you have 10 new rows of numbers coming in, that will add the numbers or whatever activity which has been stored in the macro, and that will give you the output. So that's how you can use recording a macro as well. So anywhere you don't need condition statements, looping, etc., you can definitely use VBA macros as well. But for other activities whereby you have to do your customizations, etc., whereby, for example, our finite differencing bit, we are building a customized model. So at that time, recording a macro is useless. I cannot do it. So for that, I have to build my own model and then I have to consume that. Okay, so also, within Python, have you worked on the break condition?
Break, continue, and pass.
Yes.
Yes, sir.
Okay. So is everyone familiar with break, continue, and pass? Pass is basically, I mean, you just have something to pass through. You don't really do anything there. But have you guys used this anywhere? Break or maybe continue, whichever. So maybe as a part of your hands-on activities. Okay. So the idea is a break condition basically helps you to exit a loop. So let's say I have a loop which is running from 1 to 100. But let's say I have a certain if condition which says that if a certain value equals to something, then simply exit a loop. So no matter at what time I am on or what loop number I am on, I can simply break that condition, I can exit. So so one of the examples which I can think of using the break condition can be for a barrier option. That is, let's say I'm working on a simulation, and maybe I may want to have a condition that if my underlying reaches a barrier level, I simply break that particular path. So that path will vanish. So that is one place where I can imagine that break could be useful. Continue is something which you use in Python, yes. So basically, it allows you to step over something. Continue, I need to check if it's still in VBA. I haven't used continue for some time, but I can check and get back. But break is definitely there. All right, so data types, operators, looping condition statements. Okay, so fair enough. I think this is decent enough to start. So what we can do is today we'll do some simple activities. So maybe a couple of simple hands-on things we'll do so that you get a hang of VBA, and then in the next class we can do our finite differencing scheme. So now I'll switch back to Excel. So the same sheet which I had opened earlier. So before we go there, so let's try to do a Fibonacci sequence. Is everyone familiar with what a Fibonacci sequence is? So have you heard the word Fibonacci sequence?
So we have heard, but not like remembered it right now, sir.
Okay, okay. So how many of you read novels? Have you read the Da Vinci Code or anything from Dan Brown? Because generally Dan Brown is the author who talks about all of these things in history. So things about European artists,
Angels
etc.
and demons, sir.
Absolutely, that's fine as well. So generally, those were the times whereby. So actually, that was the era when this Fibonacci sequence became popular and people started using it, either for sharing a secret or maybe using it otherwise. Now nowadays we use a Fibonacci sequence for trading as well. But there is this sequence which was developed centuries back, which we still continue to use. So it looks something like this. So we have a 0, 1. And so on. So it's like an infinite sequence. So the way to interpret this is I add the two components. So 0 plus 1 gives me 1. 1 plus 1 gives me 2. 1 plus 2 gives me 3. 2 plus 3 gives me 5. 5 plus 3 gives me 8. And so on. So this is what we call as a Fibonacci sequence or a Fibonacci series. And this will run up to infinity unless we have a certain bound for that. So this is something which we can easily accomplish through looping and maybe some basic conditional statements. So let's try to do that. So is the idea of Fibonacci sequence clear? Is it clear what we are trying to build? We are trying to build a series like this. So we can keep it slightly flexible. So we can ask for a user input. So the user can input n equal to something. So let's say n equal to 10. That is, there are 10 terms inside the Fibonacci sequence. And a series like this can be generated. So this is what we try and accomplish. And this can be easily done in our in a normal sub procedure. So can we try that?
Okay, sir.
Okay. So let me just switch. Now here inside developer, you see a visual basic on the extreme left. So can I ask you to click on that? So that will open up another window inside. So is my other window visible?
No, sir, only Excel.
Okay. So I think I just need to switch to that window because that opens up a editor window inside. Yeah, I think that's it. So this is like a blank window which opens. So here, if you see, I have my book name. So I have book one, which is just the name of my Excel spreadsheet. So and within this, you have Microsoft Excel objects. So can I ask you to do a right click here? So on this Microsoft Excel objects, can I ask you to do a right click? And here inside insert, can I ask you to create a module? And this will open up a new folder by the name modules, and you will create your module, and this creates module one inside.
So inside Excel, which option has to be clicked?
Yeah, so inside this, go to insert and module.
Okay, sir.
So by default, it creates module one. You can leave the name to be the same. It should not be a problem. So once everyone reach, yeah, okay. Now let's try to define a sub procedure. So we can do, so the way to define that is a sub. Let's have Fibonacci and two brackets. So when we talk of functions, we'll talk of function arguments. For sub procedure, we don't really require that. So this end sub is something which will populate by itself. You don't have to do that. You just define your sub, you give the name along with these two brackets and hit enter. End sub will automatically populate. Now, I would like to define a couple of variables which I'll require in my calculation. So I can have a dim. So I'll tell you how to define a variable here. So dim is a short form for dimensionalize. So dim n1 as integer. So a drop down automatically pops up, so you don't have to write the entire thing. If I just type in I and it has showed me integer. So to select that, press tab. So this is how I can define a variable. So I would like to declare a few more variables which I intend to use later. Use a dim n2 as integer. Okay. Then I can have now I want to make this slightly flexible. So I want to accept a user input so that the user can tell me how many number they want inside the series of Fibonacci, so that our code becomes flexible. So we can define a variable to hold that user input. So maybe dim maximum, or maybe maximum val or something. Or maybe I'll keep it short. Maybe max val as integer. Naturally, this has to be an integer because Fibonacci sequence is defined only for integers. I think I may require a certain temporary variable for while I do the looping and while I use the conditional thing. So let me just define one more variable, dim flag as integer. Okay, so I think these four should suffice. If required, we'll create additional variables. So that way you can create variables along the go as well. So that way you don't have to. Uh, so what we generally do is, what all things you can visualize at the start, you create those variables and maybe keep them ready. Later on, along the way, you may have a certain logic which builds up. So that time you may have to introduce other variables. So that is something which you can do along the way. You don't have to visualize the entire thing in one go. It may be difficult because this is a simple logic. But for longer models, that is not possible. You may have to work it on a piecewise basis. So for every piece, you may have a certain set of variables which would be defined. So that is something which can go on gradually. Now let's have a input box to accept user inputs. So I can have something like a max val, which I go to max underscore. Now again, there is a shortcut here. So something which you call as autocomplete. So now here I'm not typing in the entire value. So I just do max underscore, and then I think is control space. So let me press control and space. Yeah. So it completes the thing by itself. I did not type in val. I'll just redo. I tap max and the underscore. I leave it there. And then I press control and space. So maybe for those of you who are using Apple Mac OS, this shortcut may be different, but for Windows, it is control and space. Here, I will accept the input box. So I think it is input something. So I just put input B. I don't recollect exactly. It is input B or something. Yeah, it's input box. So again, something which VBA completed for me. I can tell them that please enter a number. That is, this will tell me the length of my sequence. So user has the freedom to enter any value. Now let me initialize the first two numbers because I know that my series starts from 0 and 1. So that is for sure that those values are definitely going to come in. So that is something which I can initialize. So I can have n1 equal to 0. I can have n2 equal to 1. Flag variable, I'll keep it as 1 for now. I'll keep it as 0 for now. If required, we'll see how that works. I think I may have to use flag. Let's see. Now, maybe as a first portion, what we can do is we can do some basic error handling. So when I say error handling, that basically has to do the way in which the user is plugging in numbers and how our program works. So why error handling is required? Because if the user enters a wrong input, then we should have a nice display which tells the user what has gone wrong. Because if we just give some messy error, it's not of any use to the user, right? Because the user should understand what is wrong. If I don't have basic error handling, what happens is I will have some kind of a code. So system may say that maybe code 001 or 0010 that happened. Now user will have no idea of what is code 0010. So we can actually do some error handling whereby we can have meaningful sentences to show. So let's say if the user enters a negative integer, then we can have an error statement which says that a number has to be only positive. So user knows what has gone wrong and what action has to be taken. So let's try to do that now. So basic error handling. Yeah, and by the way, this is how you can write comments inside your VBA code. So you write a single, so the key next to your enter. So the single quote. Yeah, single quote. So this single quote and your message. So if you see this has turned green. So whenever it has turned green, that basically implies that Excel is going to treat this as a statement. Now inside this, even if I write my own name, Excel will not execute that code. So it will not be a problem. So anything which you don't want to execute, that is what you write inside this single quote and the statement. Now I can do a if max val is equal to 0. Then So this is certain difference between Python and VBA. So in Python, you have a equal to operator and a equals operator. So so from your Python class, can you remember what does x equal to 1 and x equal to 1 imply? What is the difference between two?
Sir, if x equal to 2, then it means always if the value is equals to, if we put 2 for the at the place of x, then it shows true or false,
Correct.
the boolean expression. If there is x equals to 2, then it means that for everywhere we use x, it called as a constant value of 2.
Very good. Very good. So just putting in some or putting this in a statement. We won't use this, but generally giving an idea so that I don't have to switch to the whiteboard. So I have x equal to 2. So this is in Python, by the way, or x equal to 2. So this is like an assignment operator. Sorry, this is like a comparison operator in Python. So x equal to 2. So you can have a if condition here. That is, if this condition is satisfied, then you have then and something is executed. Whereas x equal to 2, this is like a assignment operator. That is, I'm assigning a value of 2 to my variable. But in VBA, we don't really have this double equals. We just work on this single equals thing. Also, indentation is something which is not required. So in Python, we know that indents are required. So after every if condition, you have that colon. So yeah, the colon thing, and you enter and it automatically indents. Now here that colon is not required. Indenting is also not required. But from code readability perspective, I always personally prefer indents. So I always insert an indent whenever I'm writing conditional statements or loops also, because those indents make code readability easy. So tomorrow, if I have to know what this if condition is, I can quickly open this file and I can see what is inside. I can keep this in the same line as if. Then that way readability becomes difficult. So from your compiling perspective, you don't need indent, but from your readability perspective, indent is always preferable. So here, if the value is equal to 0, I can have a message box. So that way I can have a pop-up which comes up with some meaningful message. So message box, I can say, please enter a valid number. Because if it's 0, I don't really have a series, right? Now I can have a else if. So else if max val is less than 0. If it's negative, again, it's a problem, right? For negative numbers, I do not have a Fibonacci sequence. Then I can have a message box which says, please enter a positive integer. Again, I can have maybe another else if max val is, if this is equal to 1, then I don't really have a separate series, right? I just have to output the first value. Then I have a message box. It says Fibonacci sequence is, and here in Python we have a comma for having that. Here a comma doesn't exist. We need to have that ampersand, which we call as the concatenation operator. So ampersand max val. Okay. And then I can have an else block. So if there's no problem, then I can go to the else condition, and within else I can have my Fibonacci sequence generator. So all of my error handling has happened in that first if else if condition. Now then I have an else block whereby if everything is fine, then I can go ahead with that. So here I can use a looping condition. So I can use a for loop. So I'll show you how to write a for here. So I can have a for I equal to 1 to max val. So slightly different way of writing for as compared to Python. So in Python, we generally have for this thing in range 0 to something. But here we don't have that. We define it in this way for I equal to 1 to max val. Then I can have x. Then I would require. I think I'll just introduce one more variable which would possibly come handy for me for swapping. Now, basically, what I'm going to do is I'm going to do a technique which we call as bubble sort. So a bubble sort will help me move through my entire Fibonacci sequence, because that's how I do, right? I mean, I have to add those two numbers and then I get the third value. Then I add the second and third value, I get the fourth value, and so on. So let me use one more temporary variable, let's say xn. Sorry, where did I go? Sorry. I think someone has raised their hand. Yes, please. Yeah, Neil, please go ahead.
So if the value is 1, maxwell equals to 1, shouldn't the sequence be 0 and 1?
So if it is one, that is if there is one value only, then rather than Maxwell, I think we can just have a n1, right? We don't need a max value.
Right, right.
Correct. So we just change that to n1. Yeah, thanks. So we'll change that. Yes.
So n1 and n2. So because when so if a max value is 1,
Hmm.
are we looking at number of values? Are we looking at the maximum value? If you're looking at number of values, then it is only n1. Looking at
The
max,
the number of values, basically. Yes.
okay, okay.
Okay. Now here I would like to. So what I'm visualizing is, imagine I am on some cell inside Excel. So finally, we are going to call this sub procedure inside my Excel spreadsheet. So inside that Excel spreadsheet, it's visualize any row or any cell inside Excel. And if I call this sub procedure there, my Fibonacci sequence can get generated in that from that cell itself. So that is what we call as an active cell. So whichever cell my cursor is on, that is my active cell, and I would like to have my Fibonacci sequence generated from that active cell. So that's one easy way of writing it, so that we don't have to have a separate array for that. So let's try to do that. So we can have an active cell dot, and I need one after the other, right? So there's something called as offset. Yeah, offset. And I have row wise. So I have So my rows will keep on changing, but my column will be 0. Sorry, 0, because I just have one column. So rows and columns dot value. This will be equal to n1. Okay, so active cell will have this, and my I will keep on incrementing. Okay. All right, because I'm going to swap these n1, n2s going ahead. So I think this should work. Let's see. Now, as a very first step, let's do xn. So just another temporary variable which I'm introducing. So xn is equal to n1 plus n2. I'm adding 0 and 1. So I have 0 and 1. So the third term should be 1. So then I do a n1 equal to n2. Okay. Then I can do an n2 equal to xn, just swapping the terms. Okay, do I really require the flag variable which I have introduced? Not really. Then now the way to complete the for is there should always be a next statement. So unlike Python, now Python handles the next automatically. VBA doesn't do that. You have to write next manually. So that way my for loop is completed. Otherwise the for loop doesn't end. If it doesn't see the next statement, VBA will not understand at which point the for loop has to stop. So this is the section for my for loop now. Okay, so my next I is done. Also, I need to end my if condition. So I have an end if. So just like I'm closing my for, I'll also have to close my if condition. So I have if and a end if, which is again linked to each other. Because if I don't do an end if, VBA doesn't understand where the if statement is stopping. So that's why end if is required. Just run through this thing once and Flag is something which I have not used. I thought we may require it, but I can just comment this out for now. Okay, max one. In here, I can write. Uh, Looks okay. So let's. So firstly, I mean, we'll have to save this file as well. So the way to save that file is go to File, or maybe you can even go to your external spreadsheet from where you have where you have basically created this code window or opened the Visual Basic Editor. And just like you save your normal file, go to Save As. However, do not keep it as .xlsx. So there is a .xlsm feature, which you call as an Excel macro enabled workbook. So I want you to save it as XLSM. I've saved my file as .xlsm. Allow me to just switch to Excel and see if things are working. If not, we'll come back and see if something is wrong. So allow me to just switch to my Excel spreadsheet where I'll call the.
So we have to save an Excel macro enabled workbook.
Yes. So if you see the name at the top of my file, it is file name .xlsm. By default, it is XLSX, but don't save it as XLSX because it's an Excel file, and now it's a macro-enabled workbook. So save it as .xlsm. Now let's try to see if our thing is working. So if I go here and if I select macros, I should see my Fibonacci. If I say run, let's enter, let's say 5. Yeah, seems to be running. Again, let's go to another active cell, go to macro. Let me enter a negative value. Let's say I do a -5 or -6. Yeah, so please enter a positive integer. So now if I did not have the error handling, something which we did, then we would have a messy looking error saying that in some code, some system level code would have come in saying that code 110 has failed or something, or violation of a certain code, etc. Now user will not have idea of what that is. So that's why this basic error handling helps. So user knows what is wrong. Also, if I enter it as 1, Fibonacci sequence is 0. Okay. Now again, if I have a valid sequence, if I have, let's say 10, 0 plus 1, 1 plus 1 plus 2, 5. Yeah, this is working fine.
Sir,
Yes.
sir, can you please repeat this part?
Yes. So go to any cell which you like. Go to
Can
macros.
you select the code once again? Just
Yes. Yeah,
lost.
we'll do that as well. So those of you who are done with the code, I'll show you what is to be done, and then I'll just switch back. So go to any cell which you like, click on macros. There you'll see the name of the macro which we have defined. So for me, I have given a Fibonacci. I say run. It will ask me for a user input because that is how we have written the code. We have asked the user to input the code. So let's say I enter 10. That is, I want these be a number of items in my series. And I press OK. So this generates my Fibonacci sequence. Let me switch to the code for those of you who are completing it. Flag we not use, so we can just delete this as well. Not required. Now I can either delete it or comment out something, but here I just deleted that. That's fine. So just to do a quick recap, we define a sub procedure. We define a few variables which we have in mind. Later on, we can introduce variables along the go as well as we progress. Here we accept a user input because there's an input box feature which VBA provides, which will allow you to plug in user inputs. We initialize certain values for our variables. Again, flag is something which I don't want. I can just delete this. I do some basic error handling. So if max val is equal to 0, do something. If max val is negative, do something. If the max val equal to 1, then just plug in then just output the first value. So my basic error handling happens here. Now, if it's a correct value which a user enters, so maybe 5, 10, 15, whatever, then I go to the sequence generator and through this, which is written in this else condition. And then I have a for loop. So this is a logic for a simple bubble sort. So something which we follow for a sorting logic as well. So something similar to that I've done here. So that helps me generate that series. I have simply introduced another temporary variable xn, which because I want to swap numbers n1 and n2 as I go ahead. So that's why I have an xn. And this is the way in which I use a for condition. And this active cell dot offset, this feature helps me output the numbers on different rows inside my Excel spreadsheet. So I can have an array as well. So as an output, I may want to have, let's say, an output array. So I go to any cell in Excel and I call the function, but for that I require a function. We haven't discussed functions now, so let's stick to sub procedures for now. Functions is something which we'll do in the next class. So is everyone getting the required output? So in the meantime, I'll keep this screen on. In the meantime, I'll just start with the attendance so that I don't have to hold you guys back. I think you'll be having something at 11:30, I'm sure. Okay, so starting with financial economics, Akash Singh is present, Achal Jain is present, Ayush Bhushan.
He is present, sir.
Okay, Adesha Hathi, Tejas Akwarik, Ali is present, Anjali Garg, Anmol Sen, Arismita Deka,
Present, sir.
Avni Mishra, Ayushi is present, Sarvesh is present.
So Tejas Akwar is present, sir.
Okay. Sarvesh is present as well. Bhavya Dan, Cherry Chabra,
Present, sir.
Diksha Chauhan, Diksha is present. Okay. Dipansha Singh.
Present, sir.
Okay. Gaurav Kadam.
Present, sir.
Gaurav Datir. Himanshu Verma is present. Jaideep Saini is present. K. Ayushi.
Present, sir.
Riya Shukla.
Present, sir.
Kriti Barwa.
Present, sir.
Mansi Singhal.
Present, sir.
Mansimran Arora is present. Manvi Kukreja is present. Mihir is present. Muskan Garg.
Present, sir.
Okay. Namrata Gaur. Neil is present. Nikhil Agarwal.
Present, sir.
Prasoot Sharma. Pratik Maheshwari.
Present, sir.
Rachit Tyagi. Rahul Ghosh.
Present, sir.
Rahul Giri. Rahul Goswami.
Present, sir.
Rajaditya is present. Rashi Jain is present. Rishabh Kothari,
Present, sir.
Ruma Keshri,
Present, sir.
Sahaj Manocha, Samiksha Chopra, Charanya is present, Shubham Jain, and Shubham Kumar.
Present, sir.
Okay.
Present, sir.
Someshwar Verma, Stuti Mehrotra,
Present, sir.
Sanika Thakur,
Present, sir.
Vinay Pawar. We are done with the financial economics class. So if you guys have any other commitment, you're free to leave. I'll quickly take the attendance for international business. Ayush Sharma,
Present, sir.
Alisha Gupta, Vidhi, Anant Jain, Anish Dopeshwarkar, Anjali Sethi, Arshada Imam, Barkha Israni, Bhavya Patel, Saloni Bujbay, Chaitra Tirodkar, Devam Pandey,
Present, sir.
Diksha Kalra, Arshada is present. Gauraja Nevatia,
Present, sir.
Gayatri Narkede, Govind Mittal,
Excuse me, sir. Anjali is also present. There was some network issue
okay.
happening.
Okay.
Thank
Okay.
you.
Savan Hake is present. Himanshi Virmani is present. Indu. Ishita Saxena. Anika Goyal. Karthik Mittal. Hasro L. Lakshay is present. Mahi Rajawat. Mansi Gupta. Mathagi Warrior. Mega Parak. Nancy Halawat. Neha Jain. Pratishtha Pradhan. Rohan Bagai. Rohit Potar. Samida Malik. Shivangi Semwal. Simran.
Present, sir.
Srishti Verma. Tanu Goyal. Tarang Kadyan. Kalyani Todkari. Twinkle Karnawat. Vaishnavi Strotriya. Vanchika Jain. Vibhor is present. Vidushi Rana is present. Yash Mehra. Oh. Okay. So we'll stop here today. So thanks for joining in.
Excuse me, sir.
Yes.
Sir, Diksha Chauhan from FE is present. I just missed my roll call.
Okay. Okay. I'll mark it. Thank you.
Thank you, sir.
All right. So great. So wish you all a good day ahead and look forward to meeting you on Saturday. And then we'll build our finite difference scheme. Now we have a rough idea of VBA. Now we'll see how to define a user-defined function. So today we did a sub-procedure, which was completely non-finance specific. Now we can try and convert those difference equations into a VBA logic, something which is not very difficult. A simple for and if condition should be good enough. So we'll see how that is done on our class on Saturday. All right. So thank you very much and see you all.
Thank you, sir.
Thank you, sir.
Bye-bye. Take care.
Thank you, sir.
Thank you.